Now we'll look at Boyle's law. This law looks at the relationship between pressure and volume in ideal gases. So in Boyle's law, we hold temperature and the number of gas particles constant. That just means that the temperature isn't changing and we're not adding or removing any particles of gas. Boyle's law shows the relationship between pressure and volume. You might recall the marshmallow demonstration or the gas law apparatus, which also showed that as the pressure was increasing, that was a result of the decreasing volume. The equation which relates pressure and volume together is P1V1 equals P2V2. And as the graph indicates, and as you saw in both the marshmallow demonstration and with the gas law apparatus, the relationship between pressure and volume is inverse, meaning as one increases, the other will decrease. A quick summary. If the temperature and the number of gas particles remains constant, the pressure of a gas will be inversely proportional to its volume. So again, as one increases, the other will decrease. Here's a sample problem. We have a balloon with a volume of 2 liters and it's filled with a gas. It's at 3 atmospheres, so that's the pressure. If the pressure is then reduced to 0.5 atmospheres and there's no change in temperature, would the volume of the balloon increase, decrease, or remain the same? So we have this balloon and it's at 2 liters and 3 atmospheres. We decrease the pressure to 0.5 atmospheres. So what's going to happen to our volume? Well, they have an inverse relationship. So if pressure is decreasing, that means the volume must be increasing. So the balloon will get just a little bit bigger because pressure and volume have that inverse relationship. Number 2, at 45 degrees Celsius, we have a container of gas with a volume of 580 milliliters and it's at a pressure of 980 millimeters of mercury. When the volume is decreased to 500 milliliters and the temperature remains constant at 45 degrees Celsius, is the new pressure going to be greater than, less than, or equal to the original pressure? All right. So again, we have this container of gas, it's 580 milliliters, and we are told that the volume decreases to 500 milliliters. So what's going to happen to that pressure? Well, if we've decreased the volume, that means we're going to see an increase in pressure because now all of the gas particles have been confined to a smaller space. And finally, oh, you already see the answer. I apologize for that. Go ahead and check your understanding, see if this makes sense. So the relationship between pressure and volume is inverse. And if the initial pressure is 5 atmospheres, will the new pressure required to condense 10 liters of a gas into 2 liters increase, decrease, or remain the same? And again, since they have that inverse relationship, if we are decreasing the volume from 10 liters to 2 liters, the pressure will therefore increase. Thanks for watching.